Who actually made the aircraft that you'll be flying on next? It may well have a Boeing, an Airbus or an Embraer logo by the door when you board, but is that badge really the answer? Well, no, not really. And to see an extreme example of why, we can simply look at a story that broke in March 2026 that went mostly unnoticed amid the mayhem of the rapidly escalating crisis in the Middle East. While drones and missiles flew to and from Iran, Boeing sent a message to their suppliers, giving them until the 9th of March to identify any work carried out in the Middle East and to evaluate what kind of impact the war would have on their production. Airbus and Embraer also made similar requests to their suppliers. And the problem didn't just involve companies doing work in the Middle East. The big three manufacturers were also inquiring about the parts that might travel through that area as they go from one supplier to the other. Now, we'll come back to the war and its effects in all of this in a moment, but the point here is that Boeing, Airbus and Embraer had to ask their suppliers about these matters in the first place. And that's because the network of suppliers that they all rely on is so vast that they couldn't simply look at a spreadsheet or a few work orders and figure out where every tiny part they need comes from. Even though all of these are certified aircraft parts that need to come from certified parts manufacturers. It's easy to look at a Boeing or an Airbus airliner and assume that it's built in one place. A single company, a single gigantic factory and a long assembly line where the aircraft slowly comes into existence from raw materials. But the fact is, modern airlines just simply aren't built that way. What Boeing and Airbus do for the most part is the final assembly, which means they're the point where an enormous number of already built pieces finally meet. Fuselage sections are arriving as major structural modules. Wings come in as fully engineered and completed aerodynamic surfaces, as does the landing gear. Cockpit hardware arrives as multiple sub-assemblies of certified avionics. And finally, the aircraft gets its cabin interior, often at a different facility, installed as a packaged assembly that still needs to be tested and signed off. We routinely call Airbus and Boeing aircraft manufacturers, but lately you may hear analysts calling them airframers, which is deliberately a bit vague. In reality, they're primarily integrators who are in charge of that final assembly and delivery to the customer. Now, of course, none of this diminishes how complex final assembly actually is. Integrating all of those modules into a single machine that will fly safely for decades and continuing to support it during that time is one of the hardest industrial tasks on Earth. It does mean that the final assembly line isn't where most of the aircraft is truly built. The real factory behind a modern airliner is a global network of suppliers, an ecosystem of companies that each specialize in building a specific piece of the aircraft and then passing it on in a highly choreographed production system. Even for something as familiar and mature as the 737, the numbers are staggering. Boeing's program for this aircraft alone involves roughly 700 suppliers, and each aircraft is made up of about 2 million separate parts. Going to the upper extreme in scale, Airbus has said that the A380 drew on around 1,500 companies across 30 countries, involving roughly 4 million individual parts, all tasked to build a single product. Describing a global ecosystem like this merely as a supply chain is, quite frankly, misleading. Now, the point isn't just how big these numbers are, but that the maker's badge on the nose or by the door only represents the last step in a long process that started months or even years earlier in factories scattered across the world, each producing components that must fit together as if they were made in the same room. And this is also where the industry's crazy long production timelines start to make sense. You may hear that an airline placed an aircraft order that they don't expect to put into service until half a decade later, and sometimes much beyond that. In reality, Airbus and Boeing can assemble an A320 or a 737 in a matter of days once they have everything they need at the final assembly facility. And yet, they have to order materials and components from suppliers months or even years in advance to make that possible. The airline is effectively waiting for space on the production line, but they're also waiting for the entire invisible list of suppliers and their parts to fall into place. Not just the big check items like the engines and the landing gear, but everything, including latches, hinges, fasteners, circuit breakers, even the lavatory hardware and the toilet seats. And once you start looking at aircraft manufacturing through that lens, then aviation news about aircraft that need rework or quality escapes that should have been caught but just weren't, and then were later traced to big or small parts from outside vendors, start making a bit more sense. And the same goes for parked, almost finished aircraft that can't be handed over to airlines just yet. To understand modern aircraft manufacturing, it helps to start thinking in terms of modules or assemblies and sub-assemblies, and in terms of the tiers of suppliers that make them all. At the very top, we have tier 1 suppliers that deliver major assemblies and systems that are big and complex enough to be treated almost like products in their own right. Large structural sections, flight deck equipment, landing gear systems, cabin interiors, wiring packages, and other integrated units that arrive ready to be installed. Engine makers are generally thought of as tier 1 suppliers too, but engines have their own supply chains and their own set of complications that we should probably explore in another video. Anyway, beneath tier 1 we have tier 2 suppliers who provide substantial sub-assemblies like actuators, sensors, valves, and smaller specialized structures that get integrated into the tier 1 modules. And then further down the food chain, tier 3 suppliers make tiny parts like fittings, tubing, fasteners, seals and springs, smaller parts that might look almost generic in nature, but ones that are just as important for building the aircraft and generally needed in much greater numbers. This tiering exists for a reason. It's not just some sort of corporate bureaucracy. Designing and certifying parts is one thing, but then building them all to the right standards involves specialist tooling and expertise that are in themselves barriers for entry to other suppliers. In other words, the industry consolidated over time with companies that specialize in their own fields. Once suppliers prove that they can deliver specific components reliably and regularly, they become very hard to replace, even when an OEM would like a bit of competition or just a backup when things go wrong, which they often do. And when that happens, even for seemingly simple parts, the whole industry can get into trouble. And I'll show you a good example of that after this. In 2024, the largest data breach in history was discovered. They called it the mother of all breaches, with 26 billion records leaked online. Chances are that your data was probably there, which means criminals may know your email, passwords, social security number, and who your family is. And they can target you with phishing scams or even go all the way to identity theft or fraud. But with today's sponsor, Incogni, you can take back control over your digital footprint and privacy. Incogni reaches out to data brokers on your behalf, forces them to delete any records of your personal data, and fights back when they try to refuse. And because data brokers keep recollecting your data, Incogni keeps removing it over and over again. Doing this yourself would mean contacting hundreds of companies, filling out endless forms, and repeating the process every few months forever. Incogni, though, automates the entire process for you. You set it up once and forget about it. You can see in your dashboard which brokers have been contacted and how many records have been removed. And with the family and friends plan, you can protect up to 4 other people with the same subscription. But that's not all. With the Unlimited and the Family Unlimited plan, you get the custom removals feature too. Just send Incogni the exact link to your exposed data and their privacy experts will handle the rest for you, which is a really nice touch. Grab it now for 60% off at incogni.com/mentor now, or by scanning this QR code. Just remember to use code mentor now at checkout. Thanks Incogni. Now, let's get back to the video.
Police are on scene confirming the...
In February 2025, a fire broke out at a factory in Philadelphia owned by a company called SPS Technologies. Thankfully, there were no fatalities, but the fire raged for several days, completely gutting the factory. This disaster caused a small but very, very real aviation crisis, which affected nearly everybody in the industry. SPS were making parts not just for Boeing and Airbus, but also for engine makers like GE and Safran. So you may ask, what parts were these? Well, SPS specialises in high-strength fasteners, mainly nuts and bolts, which might not sound like a huge deal, but as it turned out, getting all of these parts from other sources proved incredibly difficult. Well, at least to begin with. Other companies could make these parts, eventually, but getting the right certifications and approvals for each part could take weeks or even months, and it would take even longer for production to scale up to the levels that everybody needed. Again, these are literally just nuts and bolts, but you can't have an aircraft without them, and some of them were special titanium parts vital for carbon fibre aircraft like the Airbus A350 or the Boeing 787, which is why Boeing and Airbus and others had to turn to their suppliers to understand what delays this fire would cause and how quickly they could respond to it. Just like they had to about a year later when the war in Iran broke out. What all of this shows is that the supply system can be really unforgiving because it's not just enough for someone to be able to make the parts. Everything has to come with documentation that demonstrates compliance at every single step, because in this industry, the paperwork is part of the product, and with good reason, as we'll see shortly. Now, on the other hand, despite all of these risks, it still is a very efficient and cost-effective system when it works, which is why it's completely normal for everything on an aircraft to come from a supplier, whether it's bolts and washers or buttons and switches in the cockpit, or at the upper end, complete fuselage sections. But it wasn't always like this. For most of aviation history, aircraft manufacturers tried to keep as much work in-house as they possibly could, because the economics of early jet production rewarded that kind of control. But over time, aircraft became more complex, and oversight from aviation authorities became more and more demanding. So the cost of developing new models grew so much that manufacturers began looking for ways to spread risk and tap into specialised expertise. At the same time, supply chains globalised, which allowed manufacturers to gain, both industrially and politically, by awarding some contracts to competent suppliers located in the countries buying their aircraft. Again, that's the logic behind outsourcing in aerospace at its best, letting specialists build things they're best at, but this can be taken a step further. A more advanced version of that concept is the risk-sharing partnership, where Tier 1 suppliers don't just sell parts, they actually design many of them themselves. These suppliers invest capital and take on design responsibility for a slice of the aircraft, hoping to earn their money back over time. The Boeing 787 is the program that made this strategy famous and controversial. Boeing moved towards a decentralized production model where major structural and system responsibilities were pushed outwards to suppliers around the world, with the idea that completed sections would arrive ready for rapid final assembly. In theory, that meant shorter design and build times and a smoother ramp up. However, in practice, it turned integration into a brutally difficult coordination problem. When major partners struggle with the complexity of their work packages, or when interfaces between modules aren't nailed down early enough, problems can escalate quickly. Rework and the need for new documentation meant that what was theoretically a fast production model became slower than the traditional one. The 787's troubles showed that you can outsource work, but not the responsibility for the whole aircraft. Now, it's been over a decade since Boeing got into that costly lesson, and since then, the industry has been oscillating between outsourcing and reintegration. For now though, most of the aircraft still arrives at the final assembly line already finished. And the biggest examples of that are the parts that define the aircraft shape, like the fuselage sections that arrive already finished, wings and stabilisers all ready to be put on the aircraft. But the point here is that all the work done before these parts make it to the final assembly still requires dedicated tooling, massive fixtures and processes that are expensive enough that only a handful of companies on Earth can do them at scale. So when an aircraft or lessor orders an aircraft from Boeing or Airbus, they buy a production slot for that aircraft, and with it they're making a reservation across that maker's hundreds of suppliers, who then have to commit labour, materials and of course time, all priced in contracts negotiated years in advance. Again, this is why aircraft production is as much project management as it is manufacturing, with production moving only as fast as the slowest critical item allows, and that's the challenge. On paper, you can always imagine building around a missing component, but of course, an airliner can't be delivered until it's absolutely complete and configured as sold. And complete includes everything from flight critical systems down to items that sound trivial until they're not. This is why we've seen supply chain issues on things from engines to seats that force Airbus and Boeing to build planes that are physically done but commercially unusable because they're waiting for the final missing ingredients that allow the OEM to close the paperwork and hand that aircraft over to the airline. These problems don't just have to do with work on sub-assemblies. Even raw material shortages can come into play, and because they're right at the beginning of the supply chain, their effects can be even harder to predict. And believe it or not, even raw materials have to be held to the same standards as everything else, including the paperwork that I mentioned earlier. And if all of that sounds a little bit over the top, well, bear in mind here that there has been cases of counterfeit raw materials, which is something we'll probably cover in another video. Anyway, at the 2026 Singapore Air Show, executives described persistent shortages as the new norm and noted that shortages of critical materials like titanium and nickel tubing had extended lead times to roughly 50 to 60 weeks, compared to pre-pandemic norms of around 20 weeks. And that was before the Iran war. Even if Boeing, Airbus and other aerospace companies don't depend heavily on supplies in the Middle East, the transit of raw materials and other supplies through the Gulf region can still affect the industry. And on top of that, the war is already affecting the industry in another way. As we saw in a previous video, Qatar Airlines and others in the Gulf are parking some of their jets because they're expecting the war to keep affecting them for many weeks, if not months to come. So the question that everyone in the industry is now asking is, what about new aircraft deliveries? Will Qatar and other airlines in the region continue accepting deliveries of new jets from Boeing and Airbus, or will they need to think again? And the answer to that question won't just affect the airline and the aircraft manufacturer. Many aircraft scheduled for delivery might not yet be in final assembly, but long lead time materials and parts for these aircraft may already be taking shape at smaller production sites around the world. But there are some differences between Boeing and Airbus here and how their supply chains compare. Now, it's not that one of them is integrated and the other is outsourced, because neither of those labels really fit anymore, and neither company could realistically build a modern airliner without a massive supplier ecosystem. The differences here is more about how they've tried to manage dependence over time and what they've chosen to keep closest to the core of the company. Boeing, especially through the era of the 787, and really even before that, became the cautionary tale of what happens when the supply chain isn't just supplying parts, but is basically asked to shoulder a huge share of program complexity and integration risks, often without sharing any of the benefits. That's why the last decade or so has increasingly looked like a slow correction back towards tighter oversight, more in-house capability, and fewer points where a supplier can become the pacing item for the entire aircraft. And that shift is easiest to see in what Boeing decided to do about Spirit Aerosystems. After years of quality and schedule problems that had become impossible to treat as someone else's problem, Boeing's reacquisition of Spirit was framed as a decisive pivot away from a fragmented model and back towards a kind of vertical integration. The goal being better quality and stability with fewer quality escapes, like the door plug blowout that happened early in 2024. And what made that process particularly complicated is that Airbus had to be involved. In reality, Airbus had remained more vertically integrated than Boeing through luck more than anything else. In the 2010s, they tried selling some of their aerostructure facilities and only retained them because, well, they just couldn't find any buyers. Even so, they did have some external suppliers, and Spirit Aerosystems was one of them. The company produced major structures for Airbus aircraft, and that created an obvious conflict if Boeing was to absorb Spirit company whole, which Boeing didn't really want to do anyway. In the end, the two manufacturers carved out Spirit. Facilities tied to Airbus work went to Airbus, including operations associated with A350 fuselage sections and A220 wings and fuselage structures. This created a really complicated deal to split the old Shorts aircraft factory in Belfast that still does this A220 work, while Boeing acquired the remaining operations there under a Boeing-owned entity, which means that Airbus and Boeing are now uneasy neighbours in Belfast. Anyway, Airbus may keep more of their core industrial footprint closer to home, but fundamentally they still depend on the same global web of second and third tier suppliers, which means that they face the same realities and global supply risks as Boeing. The war in the Middle East, the war in Ukraine, the pandemic, they all affect Boeing, Airbus and Embraer and their hundreds of suppliers in similar ways. And keeping that production flowing really depends on all of those suppliers. So when you see a news story about more aircraft production delays, I think we can all appreciate how complex the whole process is and how many steps it depends on. Of course, wherever problems appear in the production process, ultimately the responsibility for producing safe aircraft for all of us depends on the company whose badge is visible near the nose. But what do you think? How do you think Boeing, Airbus and their suppliers will fare through the war in Iran and other crises? Let me know in the comments below. I'm Ben Watts, you're watching Mentor Now. Have an amazing week and I'll see you next time.